You can solve many polynomials by using all the operations: addition, subtraction, multiplication, and division. Well, in this video, we're going to review how we can divide polynomials. So in example 1, we're going to divide a polynomial by a monomial. So here we have 24a to the fourth b cubed plus 18a squared b squared minus 30ab cubed. And we're going to multiply that by 6ab to the negative first. Now, the part where it says 6ab to the negative first, that is important to realize that when we have any exponent to the negative first power, we want to rewrite that. So we're going to rewrite that as 1 over 6ab, and then that would be ab to the first power, which is just 1 over 6ab. So now that we would have 1 over 6ab, if I were to multiply that by this polynomial, I'm really dividing by 6ab. So now if I rewrite this, this would be 1 over 6ab, and I'm going to be multiplying all that by 24a to the fourth b cubed all over 1 plus 18a squared b squared all over 6ab, or not 6ab, sorry, over 1, and then minus 30ab cubed all over 1. And when I multiply fractions by fractions, I multiply numerator times numerator and denominator times denominator. So when I do that, this is going to give us 24a to the fourth b cubed on top divided by 6ab times 1 is just 6ab. And then I have plus 1 times 18a squared b squared is 18a squared b squared divided by 6ab times 1 is 6ab, then minus 1 times 30ab is 30ab cubed all over 6ab times 1 is 6ab. Now that we've gotten rid of our parentheses, now we just simplify each part. So 24 divided by 6 is 4. A to the fourth divided by a. When we divide like bases, we subtract the exponents. So that would be a to the third. B cubed divided by b would be b squared plus 18 divided by 6 is 3. 18 squared, or a squared divided by a is a. B squared divided by b is b, minus 30 divided by 6 is 5. A divided by a is 1, so I don't have to do anything. They just divide each other out. B cubed divided by b is b squared. So our final answer would be 4a cubed b squared plus 3ab minus 5b squared. Another example with division, you might have a polynomial divided by a binomial. Now with this one, if you can factor the polynomial, that would be the best route to use to solve. So I have a trinomial here. This is really saying x squared minus 5x minus 36 divided by x plus 4. Now I want to factor the numerator. And the reason why I'm going to factor the numerator is so I can see if x plus 4 is a factor of that trinomial on top. So I got to think, what two numbers do I multiply to get negative 36, but add them together gives me negative 5? Well, one way to start is if you look at the binomial in the bottom. Here I have x plus 4 in the bottom. I want to see if 4 is a product or is a factor of 36. And I can do 9 times 4 gives you 36. So let's try 4, and then this would be 9. If I did x plus 4, I could do x minus 9. because 4 times negative 9 is negative 36, and negative 9 plus 4 gives you negative 5. So now that I have my factored form on top, I can look at my factors in the numerator and the denominator and divide any factors that are the same. While there's an x plus 4 and an x plus 4 in the top and bottom, they divide out, and all I have left is x minus 9, which would be my quotient, my answer to the division problem. Now I can verify if that's correct because if I take x minus 9, multiply that by x plus 4, it should equal the trinomial of x squared minus 5x minus 36. Another way is to use long division. So if I were to go, I'm going to do two problems here, one with this polynomial, and then I'm going to do a traditional one with just basic numbers of long division. So over on top here, I'm going to do, let's say, 312, and we're going to divide that by, let's say we're going to divide that by 4. And over here is going to be the polynomial. So I'm going to go back and forth step by step to help you see that how we would do a normal long division with a problem you have done early on with a polynomial with division. So this would be 5x to the fourth plus 7x cubed minus 11x squared minus 7x plus 8, and all of this is going to be divided by x minus 1. Now normally, if I go back to the simpler problem, 312 divided by 4, I would think, how many times does 4 go into 31? 4 goes into 31 7 times, and I would have to do 7 times 4, which is 28. So now, if I go back to the polynomial one, I want to make sure that this number, x, matches up with 5x to the fourth. So I got to think, what do I multiply x by to get 5x to the fourth? And that would be 5x to the third. And then I would multiply 5x cubed times x is 5x to the fourth, and 5x cubed times a negative 1 is a negative 5x cubed. Your goal is always to make sure that this first term is the same. And now if I go back to the simpler one up here, once I multiply, I subtract below. So 31 minus 29 or 28 is 3, and then I bring down the 2, and my new problem will be 32 divided by 4. So now if we go back to our problem over here, I have to subtract all of this in parentheses. So if I'm subtracting that, what I'm really doing is adding the opposite. So the opposite of a positive 5 is a negative 5. And if I'm subtracting a negative 5, I'm really adding 5. So now I can combine like terms. The 5x to the fourth cancel out. And I have 7 plus 5, which is 12, x to the third. And then I bring down my minus 11x squared. Now going back to the previous problem, here I have 32 divided by 4. I got to think, what do I multiply 4 by to get 32? And that would be 8. 4 times 8 is 32. I subtract below, and I get a remainder of 0. That means if I take 4 times 78, I should get 312. So now if I continue with the problem we were having with the polynomial, I got to think, what do I multiply x by to get 12x cubed? I know that that would be a positive 12x squared, and then I multiply 12x squared times x, which is 12x cubed, and 12x squared times a negative 1 is a negative 12x squared. And just like on top, I would have to subtract below. Because I have a binomial here, I have to do the opposite. So if I'm subtracting, what I'm really doing is adding the opposite of these numbers. The 12x cubes divide out, or cancel each other off, and then I have negative 11 plus 12, which is 1x squared. Then I bring down the minus 7x. And now I got to think, what do I multiply to get x squared when I multiply x times a number? Well, x times x is going to give me x squared. And then x times a negative 1 is a negative 1x. I subtract below, so I'm going to add the opposites. The x squares cancel each other off, and I'm left with a negative 6x. Bring down the positive 8. And now I got to think, what do I multiply x by to get negative 6x? And that would be a negative 6. Negative 6 times x is a negative 6x. And negative 6 times negative 1 is a positive 6. And then I subtract below. So I'm going to be adding the opposites. So that means a positive 6 and a minus 6. Combine, 6 x's cancel each other off, and I'm left with a positive 2. So I have a remainder of 2, so I put that at the top as plus 2 all over my divisor, which is x minus 1. So that would be my answer for this polynomial. Now, if you didn't want to do long division, there is another method that may be a lot quicker and easier for you to understand, and that's called synthetic division. So what is synthetic division? Well, these are the steps you're going to use to do synthetic division. So after writing a polynomial in standard form, you're going to write the coefficients of the dividend. So just the coefficients, no variables. If the dividend is missing a term, you have to use the 0 as a placeholder. And then we're going to write the constant a of the divisor x minus a. So this is talking about our binomial that we're dividing by. And we're going to bring that first coefficient down. So whatever a is right here, so a could be a positive, it could be a negative. And one easy way of doing this is if you have a binomial like this, I would just do x minus a equals 0 and solve for x, which would mean I would just add a. So x would be a positive a, and I'm going to be doing the synthetic division with the positive form of a. And then step 2, we're going to multiply the number that we just wrote down, so our a, or the number that we wrote down, like our first coefficient, we bring that first coefficient down, and we're going to multiply that by a, and then we're going to write the answer, write the product under the next coefficient, and then we're going to add the two products, or add the two numbers straight down, and then we're going to repeat steps 2 and 3. Now this will make more sense once you see an example, but we're going to keep going until you get all the numbers written down, and whatever your last number is, that's going to be your remainder. So here's an example. If I have 3x cubed minus 2x squared minus 53x minus 6, and I want to divide that by x plus 3, well, first I want to find my a, because remember this is x minus a, but since I have a plus sign, this is really x minus a negative 3. So really my a is a negative 3. But how can I prove it without doing all that? Well, if I did x plus 3 equals 0, I would just subtract 3 on both sides, and I would have x equaling a negative 3. Now with synthetic division, I have to make sure that this is a plain x for me to use this method, which I do have a plain x here. So the first step is we're going to take our polynomial and we're only going to write the coefficients. So the coefficient is 3, negative 2, negative 53, and negative 60. And then the number I'm going to do the synthetic division with is my a, which we already found is negative 3. Okay, the first step after this is going to bring down this first number, which is going to give us 3. And from here, all we're going to do is multiply on the diagonal, and then we're going to add straight down. So -3 times 3 is -9. Add straight down, which will give us -11. Multiply on the diagonal, so -3 times -11 is 33. Add straight down. So -53 plus 33 would give us a -20. And a -3 times a -20 is a +60. Add straight down and I get 0. When your remainder is a 0, you know that this is a factor, x plus 3 is a factor of this whole polynomial. So now how do we write our answer? Well, when we do division, like when we did the long division, our answer was always start with one exponent less than the leading degree term that we had. So if this is x cubed, that means this one's going to be a 3x squared minus 11x minus 20 with no remainder. So this would be my final answer. Let's try another one. This one is the same way, but you'll notice this one's written with x plus 6 raised to the -1st power. That just means we are dividing by x plus 6. So again, you could write this as x minus a -6 because that's the same thing as x plus 6. And we just want to use that method or the form of x minus a because a is going to be the number that we are going to do the synthetic division with. So a -6 is our a, so I'm going to put that here in the box on the left. And I'm going to write all the coefficients here. So I have a 2, I have a 10, I have a -12. I'm missing the plain x, or the 1x, so I have to put a placeholder of 0 here, and then I have a 1. So I bring down the first coefficients, and I have a 2 here. So we're going to multiply on the diagonal, and 2, we're going to add straight down. So a -6 times 2 is -12. Add straight down. -6 times -2 is 12. Add straight down. -6 times 0 is 0. Add straight down. -6 times 0 is 0. Add straight down, and I get 1 here. That means, since I started with an x to the 4th, my first term is, my answer is going to be an x cubed. Then it's minus 2x squared. I don't have any x's, and I have no constant term. But this number here is my remainder. So my final answer would be 2x to the 3rd minus 2x squared plus 1 over, and then I have to use this binomial of x plus 6. And one final question here. This one has leading coefficient, or my divisor has a coefficient bigger than 1. So how do we solve these? The first thing we're going to do is we're going to take this first number of our divisor and we're going to divide the top and the bottom by 3. So if I do the top by 3, that's going to give me, that'll give me x cubed minus 25 thirds x squared plus 36 divided by 3 is, that'd be 12x plus 12. And then if I divide this part, both of these terms by 3, I now have x plus 2/3. If I make that equal to 0, I would have to subtract 2/3. Or if I think about this, let me do it the other way, like how I was doing it before. I want this to be x minus a. So this is really x minus a negative 2/3. So our a is negative 2/3. So that's what I'm going to do the synthetic division with. And I'm going to put the coefficients of my new polynomial here, which would be 1, a negative 25/3, a 12, and a 12. Okay, so we're going to bring down the first term, first coefficient, which is a 1. We're going to multiply on the diagonal. So negative 2/3 times 1 is a negative 2/3. Add straight down. Negative 25/3 plus a negative 2/3 is a negative 27/3. Negative 27 divided by 3 is 9, or negative 9. Then I have negative 2/3 times negative 9, which would be 18/3. 18/3 is 6. So I have a positive 6 here. Add straight down and I get 18. Negative 2/3 times 18, so negative 2 times 18 is negative 36. Negative 36 divided by 3 is a negative 12. Add straight down and I get 0. So that means it is a factor. Since I had an x cubed here, this would be an x squared minus 9x plus 18 with no remainder. So that would be my polynomial as my quotient. So that's how you can divide polynomials in 3 different ways.